Hello everyone, welcome to my session on monitoring microservices. So why monitoring microservices is important? So as with the microservices architecture, you build up the scalable applications, and as and when your domains are added and your system becomes more complex, and your services need to communicate with each other, right? So monitoring becomes really efficient in this case. Say an example, if you take a e-commerce and app where you may have the different modules like ordering, products and shipping, payments, etc. So as and when you go in future and more business domains are being added, so it becomes quite relevant to monitor the services. So there are key performance metrics which you should measure for each microservices in your application. You can refer as a RED method, RED, where R stands for rate. It is a number of requests per seconds based on the services you're serving. E is errors. Errors means the number of the failed requests per second, right? So why an API has been failed or what is the reason for that. Then is the duration. So duration is the distributions of the amount of the time each request will take. Right? So each request may have different uh, distribution based upon the time it will take. So how does monitoring basically help the organization? So by monitoring, you can understand the overall health of your application, how is it performing. You have different monitoring tools like to monitor the health, like Spring Boot Actuator. Then you can, it helps you ensure the API transactions are available and they're performing well. So it's a really important to monitor and handle the distributed transactions, right? Going further, so so you have different patterns and tools to monitor the services. Then you need to isolate the problematic transactions and endpoint, similar to the one we covered. Then optimize the end user experience, so which is really important. Then to get insight into the performance of each individual services that makes up an application. So how is an each service performing? Is it high? Is it giving the required result in that particular span of duration? So the monitoring of services becomes really efficient. You monitor the containers. You can set alert on the your services performance. So overall, it helps to monitor the organizational structure. So in this video, I will walk through a couple of the tools which are used for monitoring the microservices. So let's start with Hystrix. So Hystrix is an open source library which is created by Netflix and works well with Spring Boot applications. It implements the circuit breaker pattern wherein it helps you handle the failures when you are invoking a remote services, right? And it helps you control the interaction between the services where you can by providing the fault tolerance and the latency tolerance, right? It helps you improve the resilience of your system in case of the complex distributed system. So if any one of the services is down, it will give you fallback mechanisms or the fallback methods. You just need to add that dependency in the form.xml, add the @Hystrix command annotation to the methods where you need to implement the circuit breaker pattern and configure the Hystrix behavior, and also define the fallback methods which will be executed when the services are down, right? It's fail fast and has a rapid recovery, and Hystrix helps you do the real-time monitoring and alerting. You have the Hystrix dashboard as well, right? And you can monitor the services health. So the default timeout of the Hystrix is 1 second, but you can change that default timeout to 10 seconds. So you have ribbon lottery timeout equal to 10,000. So in this way you can set the default timeout to 10 seconds. So Prometheus is an open source system monitoring and alerting solution, right? So it helps you customize and produce the metrics without impacting the application performance. It gives you flexible query language from QL, and there are multiple modes of dashboard and graphing support. So also it's widely used to support, store and query the time series data that describes the actions over the time. So how does it do? It pushes the time series data. So that pushing the time series is supported by an intermediate gateway, right? So it will basically eliminate the amount of the alerts in your system, and it will only send the alert when your major issues are needs to be solved, right? So it will eliminate the irrelevant alerts on your system. Also, you have the service discovery over here. It helps you discover the target via service discovery or static configuration. It contains the alert manager to handle the alerts, and you have Grafana integration, right? So Grafana basically helps you, allows you to visualize the data which you store in Prometheus, right? So this we will cover in the next slide, but an important point that many companies these days, they use Prometheus in their tech stacks, say example like Uber, Slack, Robinhood, etc. So Grafana, it is a web-based visualization tool that is used to build the visual dashboards. Also, you have like charts, graphs, and alerts for your for the web when you are connected to different data sources. Right, so it helps you explore the data through your ad hoc queries, and you have dynamic drill down. So it gives you fast and flexible client-side graphs with multiple of options, as you can see in this snapshot below, right? So there are different panel plugins also, which helps you visualize the metrics and the logs in the way you want. You can quickly search through all your logs. You have this ad hoc queries that can be set up, and you can define alert rules for most of your metrics, right? And those rules can be moved time to time, and also allows you mix the data sources, different data sources in the same graph, right? In the same graph that can be viewed. So you can monitor your website using Grafana. You can import that dashboard and use your Prometheus data as well, right? So in this way, this is quite helpful, and this is widely being used at a number of firms um, these days. So Zipkin is another tool. So Zipkin is a basically it's a Java-based distributed tracing systems. So which it helps you collect and look up the data from different distributed systems, and it is specially designed to trace the calls between the different microservices, to analyze the latency problems if there are any from a specific call. You can use trace ID in your log file, and you can directly look up for that data using that trace ID. So you can see in the snapshot below, you have a search option where you can type in your trace ID, click on search, and based upon that trace ID, it will search in that specific log file. Then also you can query based upon the attributes, different attributes like services, the operation names, tags, and duration. So there are different modes by which you can query your attributes. So the Zipkin UI basically presents a dependency diagram, right? It shows you how many trace requests went through each of the applications. So it's a quite efficient tool. It provides the user with basic analysis option for monitoring and troubleshooting. So this is also quite widely used. So basically Apache Kafka, it is a high throughput distributing messages system. It handles real-time data feeds. It gives you zero downtime, zero data losses. It uses a publish and subscribe methodology for reading and writing the data to the logical streams. So basically you create a Kafka environment, and then you can create topics to store your events. You can write some events on those topics, read the events, and then import or export your data as streams of events with Kafka Connect, and then process your events with the Kafka streams, right? So it gives you horizontal scalability. You can scale up to millions of messages per second. Kafka basically runs on a cluster of one or more servers. You can refer as brokers, and then the partition of those topics are distributed across the cluster of the nodes, right? So so basically Kafka, it offers you transactional rights, right, which actually gives you um, exactly once stream processing using the stream APIs. um, it was developed using Java and Scala. So many companies like take an example, I'll give you some use cases which how they exactly using Kafka. As in, Netflix is using Kafka to apply the recommendations in real time when watching the TV shows. So every time based upon the your preference or your past history, it gives you some recommendations on in real time scenarios using Kafka. Then Uber also uses Kafka, wherein it helps to gather some user taxi and trip data in real time, right? It helps to compute and forecast the demand, even to compute the surging prices in the real time scenarios. Then LinkedIn, it also uses Kafka to stream, to prevent the spam, right? To collect that user interactions, to make it more better in terms of the connection recommendations in real time. So you get, say you are working in a specific firm, you get recommendations on those basis, your past history, past work history on those basis. So Kafka is widely used these days, and also it helps you give the big data integrations with Sparks, Hadoop, etc. So it's quite efficient and widely used these days. So next is ELK Stack. So basically it stands for Elasticsearch, Logstash, and Kibana. So basically they give you the availability to aggregate the logs from different systems and applications. You analyze those logs and create the visualization and monitoring and troubleshooting of your application in the real time. So first is your Elasticsearch, wherein it helps you enable searching and analyzing the data, right? It's a schema-based JSON documents. It supports and it makes Elasticsearch an ideal choice for various log analytics, right? Then you have this Logstash. It's also a data ingestion tool wherein it helps to collect the data from a variety of sources. You transform it and send to a desired destination, right? Kibana is another dashboard or data visualization tools wherein it helps to create graphs and dashboards. You have interactive charts, built-in aggregations. So you have a choice to visualize the data which is being stored. So ELK stack is also, this stack is widely used because you can easily search and maintain your analytic solution and monitor your infrastructure as well. So Postman is a widely used tool which helps to design your APIs. You can do your testing of your API. You can monitor the APIs and identify the problems with the APIs, right? Where you have some errors, your outages, or is it in regards to performance. So basically, you can have write some detailed test suites, and you can check the monitoring for specific business logic, error handling, and so on. Also, you can modify the settings in the console. That you on the top side, there's a settings option wherein you can modify. Here and below you can see different collections, and these are the APIs, and then you can see the corresponding responses for that, which is a positive in this case, status 200. So these are some of the other monitoring tools like HA proxy, which is also an open source. It gives you availability, load balancer, and proxy server for TCP and HTTP based application. Spring Boot actuator to capture the health of the applications and other endpoints it gives. Cloud forms, it helps you basically manage the cloud-based cloud infrastructures, right? You can control them and then you can manage the infrastructure. Then you have Splunk. So Splunk is also widely used. So Splunk, it helps you capture the real-time capture index, the real-time data, right? You can generate the graphs, reports, and dashboards. It uses the machine data to identify the patterns. Similarly, you have Greylog, Logstash, Heapsters, CAdvisor, Sensu, Systrix, CollectD, Pygo, Rayman, and lots more. Thanks for watching my video. If you like my video, don't forget to like, share, and subscribe to my channel for more videos. Thanks for watching.